Okay, pre-calc students, in this video we will be studying the set of trig identities called half-angle identities, okay? Half-angle identities. So obviously your heading today will be half-angle identities, half-angle identities lesson 10.5, and be sure and include today's date in your notes if you would please, okay? Be sure and include today's date, half-angle identities, lesson 10.5, and include today's date. All right, here we go. You can find these half-angle identities on page 660 if you want to turn there in your book. You don't have to, but if you want to, you can, okay? Now, notice what the half-angle identities do for you. They take a situation where you have u divided by 2, and they rewrite it so that your angle becomes just u, okay? So notice carefully, that's what these trig identities do for you, okay? Learn to recognize this so you will know when to use them and when not to use them, okay? Now, having said that, notice this really important statement down here, okay? Let's talk about this for a second. Now, notice sine of u over 2 equals plus minus. Cosine of u over 2 equals plus minus. So when do you know when to use the positive or negative sign? Well, right here, this explains this, okay? The signs of sine of u over 2 and cosine of u over 2 depend on what quadrant u over 2 lies in. So let's pretend that we have, I don't know, 120 for u, 120 over 2. Well, 120 over 2 is 60. So the sign you would use is whatever sign would be in the first quadrant, because 120 over 2 is 60. Let me give you another example, okay? Let's pretend we had 330 over 2. Okay, well, 330 over 2 is your u over 2. So what quadrant does 330 over 2 lie in? Well, 330 over 2 would be 165. Okay, so what quadrant is 165? Well, it's quadrant 2. So what is sine in quadrant 2? It's positive, so you would use the positive. So you always figure out what quadrant this entire expression is, what quadrant it's in, and then you'll know what sign to use, okay? All right, having said that, let's look at two quick examples, okay? And here we go. First example, I want you to find the sine, the exact value of the sine of 105, okay? The exact value of the sine of 105. Now, you could use previous identities, sum and difference, and put 60 plus 45. That would work, okay? But we're trying to practice our new identities, so instead of putting that, we're going to put this. We're going to find the sine of 210 over 2. Okay, 210 over 2. And why would I do that? Because 210 over 2 is still 105 degrees. Okay? Now, let's decide what quadrant we're in right now so we know, okay? Well, u over 2 is 210 over 2, which is 105. And 105 is in the second quadrant. So, when we go to find our sign, positive or negative, we say to ourselves, what is the sine of 105 degrees? Well, it would be in the second quadrant, so it would be positive. So we're going to use the positive sign in front of the radical, okay? Now let's continue on. If you look at your trig identities, sine over u plus 2, your u is 210, is 1 minus cosine of u, okay, which is 210 all over 2. So we have to find the cosine of 210. We can do it very quickly, okay? The cosine of 210 would be, well, here we go. 180 plus 30 more is 210, so my reference angle is 30 degrees. I'm finding the cosine of 210. Cosine of this quadrant is positive, so the cosine of 210 would be positive, so I end up with 1 minus, now, what is the cosine of 30? Remember, the reference angle for 210 is 30, so the cosine of 30 is square root of 3 over 2. And by the way, I apologize to you guys. It's my fault. Hold on one second. This would be, cosine would be negative in this quadrant. Sorry, cosine would be negative, okay? So the cosine of 210 is the same thing as the cosine of 30, as long as you remember that it would be negative. So we have 1 minus, and then what is the cosine of 30? Well, it's square root of 3 over 2, but it'd be negative square root of 3 over 2, okay? All over 2. Now let's continue on. Next, I would have this 1 plus square root of 3 over 2, all over 2. Now I'm okay with this being your final answer, except you have a fraction within a fraction, and I never like that, and neither do most math books, okay? So what you're going to do next is this 1 right here, you're going to call this 1 2 over 2. So now you have 2 plus square root of 3 all over 2 all over 2 over 1, because this 2 right here is really 2 over 1. Okay? Now, if you take the bottom fraction and you flip it and multiply it times the top, if you take 2 over 1 and flip it, you will get 1/2. Okay? So you end up with this right here. The square root of 2 plus square root of 3 times 1 is 2 plus square root of 3, and 2 times 2 is 4. So we cannot take the square root of the top, but we can take the square root of the bottom. So your final answer would be the square root of 2 plus the square root of 3 all over 2, because the square root of 4 is 2. And there's your answer, okay? So just make sure you understand how to use these formulas correctly, and make sure you see how to find out what sign to use in front of the radical, okay? It's really, really important you understand that, all right? Okay, let's continue on to our second example, and then we're finished with this video, okay? Let's solve this equation. And notice, students, that I'm given a domain here, okay? So we're going to find all the answers that satisfy this equation between 0 and 2 pi, okay? So here we go. All right, the first thing I notice is I have a sine squared, which is okay, but I've also got a cosine squared, and look, I've got a half angle, okay? So I have cosine squared of a half angle. So here's what I did. The first thing I did is I rewrote my cosine squared as cosine x over 2, cosine x over 2. Okay, so go ahead and copy that down. Now what I'm hoping to do is I'm hoping to use my half angle identities here to get these written in cosine of x, and then over here hopefully I can make a substitution for sine squared and make it become cosine squared, and hopefully I can solve this thing, okay? That's kind of my plan of attack. All right, now look what I did next. For cosine of x over 2, I made the substitution here, and for cosine of x over 2, I made the substitution here. Let me pause and say this. You probably say, oh, Mr. Earhart, we don't know whether we're putting positive signs in front of each of these radicals or whether we're putting negative signs in front of the two radicals. Well, in this case, it did not matter, because we're going to multiply either a positive times a positive or a negative times a negative anyways, so we'll end up with a positive either way, so it does not matter, okay? Okay, let's continue on. Okay, I don't want to go too fast. Hopefully you guys are caught up, okay? So I made a substitution here and a substitution here. Now I'm going to simplify this right side over here, okay? So I took this radical times this radical here, and remember, anytime you multiply a square root times the square root, if the radicands or the insides are the same, you just get out what's on the inside, okay? So the square root of 1 plus cosine x over 2 times the square root of 1 plus cosine x over 2 is just 1 plus cosine x over 2, okay? All right, next I can do a little more simplifying right here. So I'm going to multiply these together, put the 2 over 1, do some simplifying, and I'll come up with this right here, okay? Because your 2's over 1, your 2 would cancel, leaving you with 1 plus cosine x. Now I'm doing really, really well, okay? The only thing left to do is to make a substitution so that my sine squared is gone, okay? So for sine squared, look, I can bring down my negative sign, and for sine squared, put 1 minus cosine squared, okay, my Pythagorean identity. And now I can simplify over here take this negative sign right here and multiply it through negative times 1 and negative times negative cosine, and you'll come up with this right here. Okay? So now I'm looking really good. I'm thinking to myself, okay, I'm going to get all my cosines on one side, okay, and then factor, hopefully. So let's see what happens, okay? Well, if I bring this over, it becomes a negative 1. If I bring this over, it becomes a negative cosine. And please do not combine negative cosine with cosine squared. They're unlike terms, okay? So here's what I end up with. I have 2 minus 1 minus 1. Those cancel out. So I'm left with this. Okay, I'm going to pause a second while you guys get caught up on this, okay? So go ahead and get caught up on this. Bring your 1 over, make it negative. Bring your cosine over, make it negative. Combine your like terms, and you should have this. Okay, now I'm going to move all of this over here to create a little space, okay? Now, so I did nothing new. I just took this right here and I brought it up here, okay? Now it's obvious what I'm going to do. I can pull a cosine out of both of these, okay? So pull a cosine out of both of them, and you're left with this. And now I'm ready to take each group and set each group equal to 0. So my one group would be cosine x equals 0, and my other group would be cosine x minus 1 equals 0. Okay? So, one more page, and I'll pause and let you get caught up, okay? Now, bring your 1 over and make it positive. And now I'll pause and let you guys get caught up, okay? So I have cosine of an angle. That gives me 0, so I want to know what x would be. And then cosine of an angle, that gives me 1, so I want to know what x would be. Okay? There we go. Okay, so I'll give you guys a second to get caught up here. And here we go. Are you ready? Well, 90 degrees and 270, when you take the cosine of them, gives you 0. And 0, when you take the cosine of it, gives you 1. So there's your 3 answers. And we're finished. Just don't forget to write your answers in radians, okay? So 0 degrees is 0 radians. 90 degrees is pi over 2, and 270 is 3 pi over 2. Okay? So a quick review here, very quickly. In this video, we've looked at the power of the half angle identities, and what they do is they take an angle or a number over 2, and they let you rewrite them so that you have just cosine or sine of just the u right here. Okay? All right. I hope this video has been a help. Call or email if you have any questions.